We ready? All right. Class.
Yes.
Thank you. All right. So we're gonna go through and do some more related rates. So some of these are really interesting if you're trying to do it in your head. So best thing to do, always try and draw a picture to figure out what we're talking about. So you guys get to see some of my amazing drawings here today. So a person standing at the end of a pier is docking a boat by pulling a rope at the rate of 2 meters per second. Okay? At the end of the rope is 3 meters above the water level. How fast is the boat approaching the base of the pier when 5 meters of rope are left to pull in? Assume the rope never sags and that the rope is attached to the boat at water level. There you go. I got a word. There you go. Look at my awesome drawing now. I am so proud of
You
myself.
used the wrong color.
You're the wrong color.
You're supposed to use clear for walk.
Is clear your favorite color?
No.
Okay. Anyway, all right. So, a couple things that we're gonna have. So we're gonna be dealing with a triangle. So that should be a good start. So the triangle we're dealing with is here. So this is going to be a right triangle. And then I am looking for this direction going this way. The boat is going this way. So I'd say that there is an X direction. And over here, I could say that there is a Y direction, up and down, right? Okay. But is the Y direction changing? No, he's not changing, right? Because he's just going to keep pulling it in. Okay. And as we're pulling in the rope, the yellow rope right there, this is actually going towards the guy standing over here. And so, what do you think is happening? So, is the length of the rope changing? Yeah, length of the rope is changing. So, let's call that would be, I don't know. Since it is going to be a right triangle, let's call it
R.
R. Let's call it D. Because it's also a distance formula. So there we go. Let's use that one. So given that right there, let's go back to the values that I have. So I know I'm going to have a Y in my problem, pulling a rope at a rate of, okay, so the rate, dock the boat by pulling a rope at the rate of 2 meters per second. So the rope is changing at 2 meters per second. So let's go back over here. So that means that the D is changing. So that's a D, DT, or DDT. So I'm changing, I have the derivative of D in terms of time, and that is changing at 2 meters a second. The end of the rope is 3 meters above water level. So that means that the Y is 3 meters. Okay, let's see. How fast is the boat approaching the base of the pier? So I'm looking for dx dt. I'm looking for dx dt. is what I'm looking for. And it says when 5 meters of rope are left. Okay, 5 meters of rope. So that means that D is going to be 5. Okay, there we go. All right, so we are dealing with a right triangle. And this is kind of why I wanted to identify the different things. So it is going to be a Pythagorean theorem here. And on this triangle right here, it gave us some values that are going to just always be there. So I want to know, so this is always going to be 3. And then my D value, they said the D value is going to be 5, right? Yeah, so that's going to be a 5. Isn't this a right triangle? Yep, it's a right triangle. Now, mental math. What's the X value going to be? Take a guess. She's saying 4. 3, 4, 5. It's a special right triangle. So it's 3, 4, 5 is a special right triangle. Another one, 5, 12, 13 is a special right triangle. A couple of the other ones. So if we did the Pythagorean theorem in my head, okay, it would be 25 minus 9 is going to be 16, right? 25 minus 9 is 16. And if we're doing the Pythagorean theorem in my head, square root of 16 is 4. So I'm going to have that one has to be 4. So my X value is 4. Okay, are we ready yet? Alrighty. So I know that I'm gonna have a right triangle, so I'm gonna have a couple things right here. So I'm gonna be, I have all these things right here. So the only one I'm not gonna have, so it's gonna be, let's see, x squared plus y squared is equal to d squared. So from here, let's go ahead and take the square, or the derivative of each item. So derivative of each item, this is one from last week. So derivative, this is going to be a 2x dx dt plus, this is going to give me 2y dy dt, and this one over here is going to be 2d d d dt. Now let's start plugging in what we have, and we can start solving for what I'm looking for. I know I need to find dx dt, right? That's what the goal of the problem is, find dx dt. So this is going to be 2 times x. My x value was 4. And that's going to be a dx dt. 2y. My y is 3. Now, dy dt, what is the change in y? Zero. It's not changing, is it? So there is no change. So my dy dt, so it's not changing, so that stays the same. So that's going to be a 0 is equal to 2 d, which is 5, and dd dt. So my change is going to be 2 meters per second times 2. So that middle piece right there, anything times 0 is? 0. Okay, so basically, it's going to be, all this over here is going to be what? 20? 20 is equal to 8 dx dt. Divide by 8 and reduce. My dx dt is going to be 20 divided by 8. What's that? At least 4. So that's going to be 5 over 2.
Wait, why are you dividing by?
8.
Like what you reducing by?
Yeah. 20 divided by 8. Did I mess it up? 4?
So you're dividing by 4. Okay.
Yeah, so by a factor of 4, 5, 2. There we go. And that's going to be, what are my units of this change? Meters per?
Second.
There we go. And now, what made this whole problem possible?
Picture.
The picture, right? Drawing a picture. So your picture has to be at least as good as mine.
This is literally physics class.
Yes, this is better than your art class.
Physics class.
Yeah. But we don't have to have a whole class just on physics. This is the physics of actual math. So, make sense? Kinda? Yeah, in your physics class, you guys only do the algebra-based physics,
Yeah.
not the calculus-based physics. So, anyway. So, here's another one. A revolving light located 5 kilometers from a straight shoreline turns at a constant angular speed of 3 rad per minute. What speed is a spot of light moving along the shore when the beam makes an angle of 60 degrees with the shoreline? Gotta start by drawing it, right? Okay. So, let's start with my shoreline. Okay, I got my brown sandy beaches, right? Look at that. Got my sandy beach. And then we have, what is it, lighthouse, right?
Yeah.
Okay, so my lighthouse is going to be,
Just use a red rectangle.
it's gotta have like those stripes on it. I don't know why.
To see better? Question mark? I don't know.
There we go. Okay, and since this is a wonky drawing, I'm gonna say, I'm gonna go this way to make my triangle, and this way here. Let's see. 5 kilometers from a straight shoreline. Right there. Turns at a constant angular speed of 3 rad per minute. So it's turning, so it's going 3 rad, so it's rotating. So as a rotation, so my theta per second or minute?
Per minute.
Minute, okay. I have to put second. Dang it. Come on. There you go. 3 rad per minute. So, d theta dt. So it's an angle that is rotating. Okay, so I know I have to have a theta in there somewhere. And what else did we say about our theta? The beam makes an angle of 60 degrees with the shoreline. So, with the shoreline. So that means on the shoreline, it's got to be 60 degrees. So that means that my theta is not here. My theta is over here. Ah. Come on. That theta's right there, and this one's going to be my 60 degrees. Is my theta. All right, do you think this one's going to be getting smaller or larger?
Direction.
So the direction of the rotation, right here, 3 rad. So as I go, this should be getting bigger, right? So this angle should be getting bigger since it's positive. Okay, so right there, so that means that this should be traveling this way. So I should have a x value here, I should have a y value here, showing turns on speed. What speed is the spotlight moving along the shore when the beam makes, so it's actually the speed of the spotlight along the shore. So that means that it's going to be a dx that I'm looking for. I'm looking for the dx dt because it's moving along this way. So I'm looking for that rate of dx dt. Now, let's see. Let's do a little bit of trigonometry. Just a little bit. Yeah, my other original is not to scale, so. So if that's a 60-degree angle right there, what's the small angle that I'm missing?
30.
30. Okay, so now I could actually use some basic trig. So I need to find what my x is going to be right here. I need to find what the x is. So I could use sine, cosine, tangent. What do you want to use?
Sine.
Sine? Okay. What is sine in trigonometry?
Opposite adjacent.
It's some old hippie caught another hippie tripping on acid.
Geometry, I never used that.
Oh, because you never learned it.
I used SOHCAHTOA.
Oh. If you knew it, then you wouldn't have said the wrong answer.
I
Okay. Now, serious question here. You ready? If you're using sine, you would have to have the hypotenuse, right?
you know.
So, do I need to use that side right there?
No.
No, I don't have the sine, but do I need to find the sine? I don't have it, and I don't need it. That's important. The x, I don't have it, I do need it. So that means I'm going to use something that is going to either include the x and the 5. What do you want to use? Tangent. I'm going to use tangent. So I could do it from the 60 or the 30. Okay? I prefer from the 30, but you could do 60 if you want. Okay, so if we're doing it from the 30, 30 is my reference angle, so it'd be tangent of 30 so tangent's 30, tangent of 30, what is tangent? So it's opposite over adjacent, right? Opposite is x, adjacent is okay, so we're going to try and get x by itself. I'm going to multiply both sides by 5. So it's going to be, those cancel. Now tangent at 30. Tangent at 30. So if you remember from the unit circle, so think about it. 30 degrees is the small one, isn't it?
Yeah.
So that means that the x value is bigger, isn't it? Okay, because it's not up very high. It's lower. So that means the x value is greater than the y value. So the tangent is going to be y over x. So that's going to be 1/2 over rad 3 over 2. Okay, multiply by the reciprocal, so it's 1/2 times 2 over rad 3. And then rationalize. If I rationalize this, I have to multiply top and bottom by rad 3 over rad 3. So by doing that, rad 3 over rad 3 is just going to give me
Rad 3 over 3.
rad 3 over 3. So this is going to be 5. Tangent 30 was rad 3 over 3 is equal to x. Are we caught up with this so far? Okay, so I'm going to erase my work for this. Now that I have that x is going to be 5 rad 3 over 3. Now all this right here was to set up my problem. all of this was to set up my problem. So, I now know with values what the x is, so I found all that. So now I can go back and do the formula, and I know because I have a change in my theta, I need to have this as a trig formula. So it's got to be trig, so it's basically what I already have. I have the x and the y, and right here, my distance, okay, on this one, is not going to be part of my whole triangle, so I don't need that. So what I can do is I can do the same thing again, but this time I'm going to set it up with what I have over here. So it's going to be tangent theta is equal to y, right, over x. You ready? No? Maybe? Hopefully? So I could set this up as a quotient, or I could actually do a little bit of math first and turn it as a product. I don't like having the quotient. I don't like that. So let's go ahead and multiply both sides by x. So it's x times tangent theta is equal to my y. And now I can go through and do my product rule here. So my product rule, so this is my f and this is my g. So f prime is just going to be 1, right? Okay. So it's 1 dx dt times tangent theta plus x times, what's the derivative of tangent? Huh? Secant tangent? Secant square. So we get secant square equals, oh wait, not equals, because I took the derivative of that, it's going to be d theta dt is equal to the derivative of y is just dy dt. Now, again, is sine over cosine. So if you forgot what this is, to try it, you can go back. You don't have to memorize this, but if you come across it, sine over cosine, so if we treat it like it is a quotient rule here, so this is my f and this is my g, so f prime, derivative of sine is cosine, g prime, the derivative of cosine is negative sine, so f prime g minus g prime f, so it's going to be cosine f prime cosine, so f prime g, so times cosine, minus g prime is negative sine times f, which is sine, over cosine squared. And the minus and negative does what? Makes it to a positive. So if you forgot, so cosine times cosine is cosine squared. plus sine times sine is sine squared. Now, what is cosine squared plus sine squared? It's an identity. There's only one thing it could be.
One.
Yeah, it's 1. Right? So that's going to give me 1 over cosine squared, which is the same as saying secant squared. So if you get lost with that, you could always just go back and try and work it out as a quotient rule. Okay, let's start plugging in what I have. So, what is tangent of theta? My theta is 60, right? Theta is 60. So 60 degrees. Okay, on my unit circle, the y is greater. So it's going to be, I'll go to the next one so I can do this. So tan 60, it's going to be rad 3 over 2 divided by 1/2 times the reciprocal, which is 2 over 1. So we just get rad 3 for that one. So as we're plugging this in, that tan 60 is going to be rad 3 dx dt. Dx dt is what I'm looking for. Plus my x, which we said our x is going to be 5 rad 3 over 3. Secant squared. Okay, so secant is my cosine, right? Secant's the reciprocal of cosine. What's cosine at 60? No, that one's 45.
Okay.
It's going to be 1/2. So cosine at 60 is 1/2. So it's going to look like this. Okay, that's what secant is, right? But if it's the reciprocal, it's the reciprocal of 1/2. What's the reciprocal of 1/2? 2. Okay. And if it's secant squared, that would be 2 squared, which is going to give me 4, right? D theta dt. My d theta dt is going to be 3. dy dt. dy dt. What is my y changing? 0. It's not changing. There is no change to the y, so that one stays. So there is no change. All right, let's do a little math. Blah, blah. So that's going to be 20 rad 3. And let me pull it over to a new page, because I hate getting to the bottom. So we said rad 3 dx dt plus 20 rad 3 move it over there to the other side. I'm going to get rad 3 dx dt is equal to negative 20 rad 3 over, oh, not over yet, but, and then divide by rad 3. So it's going to be dx dt is equal to negative 20. What are my units? What are my units on this one?
Radman.
What is changing though? It's kilometers, isn't it? Because we can't go by the d theta because that's a rotation, isn't it? It's not the same as the same units as x. I'm not going to say my x is, changing like that. So my x and y are in kilometers, so it's going to change like that. So that's going to give me in kilometers per minute. Alright, I said a lot. Did I lose everyone? Kinda. So on these problems right here, each one of these problems is a puzzle. And you have to look at the information given to you. Because we are given a theta, I had to have a trig problem that actually had a theta in there. I needed to set it up like that. The previous problem, I didn't have that. I had just an x, y, and d, my x value, my y value, and the d value. And I think I have one more example.
You did have one more example, but you skipped it.
I skipped it.
It was the other page.
I skipped one?
Oh, is that one?
No, because we
No.
did this one.
Slide number 6. It's like a reticular pool.
Oh! Okay. Oh man, that's my fault. I'm sorry.
That's why I was like, oh.
Oh.
I was writing on the wrong question. I was like,
Oh.
okay, this is slide
Okay,
6.
sorry. Wow, I am horrible today.
I thought you wanted to skip it. I was like,
No, I don't, because this is one of the ones that you're gonna actually have to do, and this is every year is like an AP question.
wow. Yeah.
I know, right? So we're always draining something.
Mentality.
So I will pick up this one tomorrow, and I'll give you guys some more time for this. Okay, make sure everyone likes, share, and subscribe. I will finish this one tomorrow.